Are we recording? Okay, welcome back. And now we are, yes, we're in school. That's the bell. Go with it. Okay. We are simplifying, we're getting into our exponent unit, okay? And this is the first lesson of our exponents, simplifying exponents, okay? And so we already know that like an exponent is this little number that's right here in the upper right-hand corner. And no, this is not 2 times 3. It's 2 times 2 times 2, which is equal to 8. And remember, whatever I write on the board in the video, you're writing in your notes, okay? So, yes, these little numbers in the upper right-hand corner, the exponent, that's what we're talking about in this unit. So you already titled the unit exponents, and you already wrote simplifying, okay? So let's take a look here. We've never had a situation before where we had a negative exponent or 0 for our exponent, okay? And so I'm going to tell you how we handle both of those. Very simple. We cannot have a negative exponent, okay? We cannot have it. So the way that you get rid of a negative exponent is by flipping it down to the denominator or flipping it up to the numerator. So here we have a whole number, so we only have the option to flip it down to the denominator. So when you flip it down, what happens is that negative symbol goes away. Okay, and so then all you have to do is simplify. So that's not 9 times 2, it's 9 squared. So 9 squared is 81. Okay, then we have, I don't care what it is. It could be an elephant, a giraffe, negative 3.6 raised to the 0 power. Anything raised to the 0 power is always, 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 always equal to 1. It could be 2 thirds raised to the 0 power. That's equal to 1. It could be negative 17.5 to the 0, raised to the 0 power. That's equal to 1. So make sure you write down those examples. So what I'm going to do, I knew that was going to happen. Just hold on a second. Okay. So what I'm going to do is, okay, make this bigger. So I would like us to practice, okay, A through E. So let me make it a little bit smaller so it fits in there. Okay, so you're going to practice A through E, and then we'll do that live in class. So now I want you to write down these next examples here, okay? A, B, and 27. We're still simplifying. Let me make it a little bit bigger for the video. We're still simplifying, okay? And the best way, but now you can see that we're dealing with multiple variables in the expression, okay? So here's the secret, here's the key. All you have to do, okay, is address one at a time, one element in that expression at a time. So the 5, there's nothing wrong with the 5, so we just bring over the 5. A to the third, that's fine, so we just bring over a to the third. But we cannot have a negative exponent, so that has to be flipped down to the denominator to get rid of that negative exponent, and that is your final answer, okay? Same thing here. You have to look at each element in this expression individually, one at a time. So the 6 is fine. That's doing nothing, so that stays where it is. That a to the negative 1 can't have a negative exponent, so that gets flipped down to the denominator. Okay, and that c to the negative third can't have a negative exponent, so that also gets flipped down. So when you flip it down, it gets rid of that negative exponent, so that comes down. And then we also have d to the 0 power. So anything raised to the 0 power is equal to 1. So that's your final answer, 6 divided by ac to the third. Okay? And here again, here's an example of something already in the denominator. So how do we get rid of that negative exponent? By flipping it up. So our final answer is x to the 5th. Okay? So now here's A through D. We're going to do those live in class. Okay? And now part 3 is writing terms in scientific notation. Okay? So let's take a look here. Part 3. Okay, first of all, we have to know exactly what scientific notation is or looks like. Okay, so first of all, okay, you've already written this down. In order for it to be in scientific notation, it has to have one number to the left of the decimal. It has to be multiplied by a power of 10. And it could be, a positive or a negative number. But this is what it needs to look like. Again, it has to have one number to the left of the decimal. It has to be multiplied by a power of 10, and it can either be a positive or negative exponent, okay? So in this example, this would not be written in scientific notation because there is no decimal there, okay? This one is written in scientific notation. That's fine. This one is not because it's not being multiplied to a power of 10. That's being multiplied by 100, so that does not work either, okay? So now we're going to talk about writing numbers in scientific notation and then the reverse, okay? So here we are. We're going to write this number in scientific notation, okay? It's the approximate distance between the sun and Saturn. So this number is 1,430,000,000, okay? And we have to write this in scientific notation. Well, I already know that there only needs to be one number to the left of the decimal, so I know it's going to be 1.43 times something to the power of 10. Now, since this is a whole number, everyone go ahead and write whole number, okay? What that tells me is that the exponent is going to be a positive number. When you have a whole number, when you write it in scientific notation, the exponent will be a positive number. But the way to do this, guys, is we have to know where the decimal is presently located. The decimal is always on the end, right? And we know that it needs to be between the 1 and the 4 because there can only be one number to the left of the decimal. So we have to, how many times do we have to move the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move the decimal 9 spaces to the left. So that's the exponent that goes in our answer, okay? So again, when you have a whole number, the exponent will be positive. Now, here's a decimal, okay? So everybody write decimal, okay? When you have a decimal, when you're writing this decimal in scientific notation, the exponent will be a negative number, okay? So first of all, here's the decimal. The decimal needs to be here because we can only have one number to the left of the decimal, okay? So I know that the answer is going to be 1.0 or just 1 times 10 to who knows? We don't know just yet, okay? But we do know that whatever that number is, it's negative, right? Because we started out with a decimal. When you start out with a decimal, you know you're going to have a negative exponent. So we had to move the decimal how many times to get to this point? We had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had to move it 10 times, and that's how you write it in scientific notation. Again, it has to be only one number to the left of the decimal times the power of 10. And then since that was a decimal, we had a negative exponent. So I want you to go ahead and do A through D as practice examples, okay? And then part 4, which is the reverse, okay? So we took it from a whole number and a decimal and wrote it in scientific notation. Now we're going to do the reverse. They're going to give it to us in scientific notation, and we have to write it in regular standard form. So go ahead and write these 2 examples down, okay? So I'll give you time in class to write it before I proceed. So basically, that's a positive exponent. So I know it's going to be a whole number. So I know that I have to move this decimal 6 times to the right, basically, okay? So if I have 5.5 and I have to move it 1, 2, 3, 4, 5, 6, put the decimal there, 1, and just fill in the zeros, right? Comma, comma. So we have 5,500,000, okay? That's how you take it from scientific notation and write it in standard form. Okay, and the reason why I knew to move it to the right was because that was a positive exponent, which means I knew I was going to have a whole number for my answer. Now we have a negative exponent, which means we're going to wind up with a decimal. Okay, so here, so 3.1. Okay, so being that I know we're going to wind up with a decimal, okay, that means we have to move the decimal place to the left. How many? 3 times. So we're going to go 1, 2, 3 and fill in the 0. So our final answer is 0.0031. That's our final. And what you need to know is that this means exactly the same thing as this. Okay, they're just written in 2 different ways, but they mean exactly the same thing. So hopefully that's helpful. Just remember that when you have a positive exponent, you're going to have a whole number for your answer. When you have a negative exponent, you're going to have a decimal for your answer. Okay?